Out. So this is your class right here. This is week. Last week we couldn't have a class session, but I put something for you to read. Is more of reading, and it's a very interesting read. It's about quality management. If you haven't read that, you can just take it whenever you get a chance. You can read them. Today we'll be focusing on something else, which is the on process management, statistical process management. So that's a bit our area of focus today. And this is you can see it on the models. The assignment due today will be classwork 8. You can submit it tomorrow. I will accept it. Then homework 2. I will get it ready by tomorrow evening, and it will be there for you to complete. And you can access both of them from the models, like I said earlier, by clicking on the models, scrolling down to model 8. This is where you see the PowerPoint we're using today and the spreadsheet. And homework 2, I'm going to put it after tomorrow. By tomorrow evening, it will be there. Classwork 8, I'll put it as soon as the class is over. I'll put it in.
And all of these assignments are solo assignments, right?
Huh?
All of these assignments are solo assignments, right?
Classwork 8 is group assignment. Homework is group assignment. Only test is the
Oh, okay.
test and exams are the sole assignment.
Okay, thank you.
Except there are some people that I gave the permission to do because their group is disbanded. So anyway, let's go back. Now today, like I said, we're focusing on statistical process control. Now, when we say statistical process control, we are referring to the how we apply statistical methods to make sure that the process can be manufacturing process, it can even be a service. So we applied statistical method to make sure that that process meet the standards. Yeah, usually, or I would say in general, all the processes are subjected to two main degrees of variability. All processes in this situation, two main variability. One is the one that we call the natural variation. This one is actually, I mean, it's a small random difference that naturally occur, within a stable process. For example, let's say a company that make bottles for for soda, or that makes a soda cans. Some of the bottles or plastic bottles they make might be labeled as that they contain 500, say 500 milliliter. But sometimes, um, even that doesn't mean that they will contain exactly 500 milliliter. Sometimes it might be 499 or maybe 500 itself, or even 501. But that is what's called natural variation. So in this case, like I said, it occurs within the process, even though the process is in statistical control. Um, another example I can give you here is the weight of packaged products. They might say that the weight is 5 pounds. If you weigh it, it might be a little bit it might be exactly 5 pounds. Or if there's gonna be a difference, it might be maybe 5.1 pounds or 4.99 pounds. People don't really complain about that much if it's too slim, less slim like that. And this can happen, because of some kind of say small random difference that naturally occur within a stable process. And it doesn't really indicate a problem. Every process have these two categories. First one is natural variation. The one that causes problem is one that we call assignable variation. So in this case, uh, we can it's usually caused by something, there's a reason for that, and it is be noticeable, and then it is a problem. Things like a bottling plant that claim that they are making 500 milliliter of, you know, for their soda can is size. The size of the soda can is 500 milliliter. But when you weigh it, it is like 460. I mean, if I'm a customer, I will feel cheated. You know, unlike the other one, natural variation, which might be maybe 499. I don't feel it, but 460, that there's a problem. So factors like machine wear or misadjusted equipment or even fatigued or untrained workers can, or even new batches of raw material that have a potential source of that can cause problems. The bottom line is that when we have this kind of variation, is a problem. The engineers have to look into the machine to find out what is going on. So so this every process is basically is affected or is subject to these two type of variation: the natural variation, which is normal, uh-huh, or the artificial, assigned or special variation, which is a problem. Now, so the job of the operation manager this time uh, is very, very important in trying to, well, keep the natural variation the way it is, but the assignable variation job is to make sure that to eliminate assignable variation completely. In other words, the main role of the existence of these two type of variation makes the work of the operation manager to be very clear. First one is to ensure that the process is capable of operating under control with only natural variation. The second one is that the operation manager has to identify and eliminate the assignable variation completely so that the process can, the process will remain under control. I mean, if you have a customer that let's say that is a grocery store, and then let's say Pepsi that you're supplying them, some of them have full, some are not, some are half, they will reject it. And when they reject it, you lose money because you already spend money to ship it to them. So making sure that the natural variation stays and the assignable variation is eliminated, make sure that it ensures that your supplies are not rejected or even you're not even sued. So now there's in 1920 a researcher called Walter Shihat developed what he called the control charts. Today we use that control charts to measure natural and assignable variations. Control chart, correct. So with the control chart, you can check the output or the during the production process, and then see if the process is out of control or if it is is within the manageable limit. So the control, and that will be our focus today: how to draw those control charts and use it to monitor a process to make sure that it's not a process that is out of control. If for some reason we discover that there is a part of the process that is out of control, then the engineers will dig in to figure out what is causing that variation. So in other words, a process is said to be operating in statistical control when only the source of variation is the common or natural causes. Now, the process must first be brought into statistical control by detecting and eliminating the spatial variations, which when they happen, they indicate a problem. So after this is done, after we eliminate the assignable causes of variation, then the performance of the process becomes more predictable, and the ability to meet customer expectation also become enhanced. So to put it simply, the objective of a process control system is to provide a statistical signal when assignable causes of variation are present. So with that kind of signal, the appropriate action will be taken immediately to eliminate that assignable causes of variation. So because this is a statistical method, we need samples of the product or the output. So those samples, it can be selected maybe 5 samples per day, or even 4, or even 3, because both the natural and assignable variation, because of because we're going to be using the statistical method to check this. We use this averages, samples, and the sample averages. So if it goes above the average or below the average, past the upper control limit and lower control limit, then there's a problem. But it's within those limits, then the process is under control. So normally individual pieces of output tend to be more erratic, and it become more difficult to find if there's any trend in them. So let us quickly look at some of these control charts. Let's I've already explained that they were discovered, I mean, they were developed by that scientists with the goal of using it to distinguish between natural variation and variation due to assignable causes. Now, the process of building the control chart is simply based on the concept that is shown here. If you can see it here, see this one, if you look at this process here, see that this one is out of the line. This line is the center line. This one is out. This one is a little bit inside the line. This one is, they keep fluctuating. So this one is out of control. But if you look at this one, it's in control. Let me expand it so you can see it. See? And look at this one. See, this is the middle line, and it keeps shifting away from that middle line. So it's basically out of control. Let me make sure I see this. Okay, good. But look at this one. Is within that line, so it's in control. And this one is in control too. And the variation of from the common cause is not big. This one is on control as well, but there's too much variation. So maybe returning to where it was before. Yeah. Now, the two popular actually there are 3 of them we might be using. Might be using 3 of them, but the two popular ones. We have the X chart and the R chart, and then we also have the P chart. Yes, we have P chart as well. Sure, I've seen. Yeah, we have P chart as well. So the S charts tell us whether the changes have occurred in the central tendency of the process. And some of these changes might be due to factors like the wear and tear of the tool, or a gradual increase in temperature, or a different method used on the second shift, and so on and so forth. The R chart values simply indicate a gain or loss in dispersion. It shows that a gain or loss in dispersion have occurred. And again, such change might be due to, I mean, if it is an industrial process, might be attributed to one bearings, or a loose tube is being used, or an erratic flow of lubricants. And I mean, it can be any of this for any of these reasons. Okay. I forgot to put P chart here, but we're gonna do P chart. Now, when we are designing this, when we are putting this control chart together, we have for example, if it is the X chart, yeah, X bar chart, because this is a mean. If we know through past data that the standard deviation, I mean, we need the standard deviation basically because it tells us the deviation from the center. Now, when we set it up, if we know the value of the standard population, when I say standard deviation, I'm referring to the population standard deviation. We know the value, we can then use these formulas here to set up the upper and lower control limit. The upper control limit is S bar plus Z times standard deviation, where Z represents the number of standard deviation from the mean. X bar represents the mean of the sample mean, or a target value that is set for the process. And then delta X bar means the standard deviation or the sample mean. So, but most time we don't know the value of the population standard deviation. In that case, we'll be using there's a chart that we'll be using. It's right here. Give me 1 minute. Yep, this is the chart right here. Let me make it big for you so you can see it. So it is called in 1 minute. Just a minute. Yeah, it is called that was the table of values, or the main factors for it. Yeah, table of values. You can see the sample size right here. You can see the main factor. This table was developed by people who have been in this industry for a long time, and they're able to make an estimate of what this mean factor, upper range and lower range values that we'll be using in place of the population standard deviation. So they were able to estimate it. I mean, not 100% accurate, but with a reasonable level of accuracy. So we have check it. So because we don't always know the value of the population standard deviation, we can now use that to get it. But before we get deep into this, let me show you what a controlled chart really looks like. I have my Excel. Look at this question here. It says, create an X bar control chart that explain what the control chart show. Sorry, create the S bar control chart and explain what the control chart show pertaining to the process being in statistical control. Use the data provided in Excel to which include the given data set plus the following: lower control limit of 6, upper control limit of 16, and the center line of 14. So in this case, the values are given to us. I can see, so I put them here. So just to show you what a control chart might look like. I'll give you 1 minute. I want to check something here. Okay. So I'll take you there and put all these numbers in. Okay. So this is the center line of 14, upper control limit of 16, and lower control limit of 6. And this is the data set we are giving.
Excuse me,
Yeah.
Prof.
Huh?
Are you recording?
It's being recorded, yes.
Oh, thank
6, 16, and 14. So I put them here, and you're given the data set just to show you how the control chart looks. So what you're gonna do is just to now this is the center line, this is the upper control limit, this is lower control limit, and this is your data set. So the first you do is now is to put all this, make all these numbers that represent the mean or the center line, then the upper control limit and lower control limit, copy them all the way down. So you can just highlight it and copy them down. Now, this is the data set they give. Like this is what you're going to plot together with this. So you see any of these numbers go out of these lines that are the boundaries, that means that number is out of control. So to plot it, all you gotta do is to make sure I've seen it, is to highlight it, all of them, the last one, then click on insert. It is a line graph, so you gotta choose which one of these, see? And they can see it right away. So, because they didn't tell us what data set is, what this data set, what kind of data is it? Is it scores in a test, or is it prices of something? They didn't tell us, so I'm just going to leave the chart title. Yeah. I can see this is the lower control limit. The green is the upper control limit, and you can see that there are 2 points that are outside. Those are the ones that represent a process that is out of control. Yeah, because if you're not out of control, they will be within inside these 3 lines, not above this one and not below this one. So that's to give you an idea. But in this case, you are given the lower control limit. I mean the center line, the upper control limit, and lower control limit. But the one that we'll be doing, you will require to calculate this upper and lower limit using this formula here. So now that you know how a control chart would looks like, can move on to this next section, which is some key points on the main that you need to understand when you do a control chart. I'm going to use the control X bar chart as an example. It says because the process standard deviation, the population standard deviation for the process is not known or not available, we usually calculate the control limit based on the average range instead of the standard deviations. Now, and this table 1, like I say, provided the conversion table we'll be using for this. Okay. And then we call it the table for the X bar chart. We'll be using the mean factor A2, and this is the sample size. So it depends on the sample size they give you. Like they have it from from number 2 to 12. In most examples or exam examples, you'll be giving like 10 samples, 8 samples, and so on and so forth. 10. Once you get it, then now we can now calculate the control limit unit using these formulas. Upper control limit equals X bar plus A2 R bar. And then the lower control limit will be S bar minus A2 R bar. This part A2 is the value that you find in this table here. Okay, so you can see A2 right there. Then the other one, S bar and R bar, you have to calculate it with the data set that we're giving to you. And R bar represents the average range of the samples, and S bar represents the mean of the sample means. Okay. Now, enough of the talking. Let's do an example so you can see what I'm talking about. It's a look at this question. It says a construction company uses a machine to manufacture concrete slabs. To ensure the slabs meet the weight specifications, the quality control team collects weight measurement from 5 randomly selected slabs each day for 10 days. The weights are shown in Excel. Say plot the X bar. I can say we already see. Make sure you're seeing it. Yep. It's a plot the X bar control chart showing the daily averages with the upper control limit, lower control limit, and center line. Then B says, is the concrete slab production process statistically under control? We don't know until we do the plotting. Let's go to the, let me take you to the Excel so you can see it right here. But 2, I'm gonna make it to be bigger. Make it to be bigger and better. Okay, I'm gonna make it 14 or even 16. Let me make it 16. Okay, 16 should be good, better. Okay, good. Now, this is it. That's what the question is talking about. It says a construction company uses a machine to manufacture concrete slabs to ensure the slab meets the weight specifications. The quality control team collect the weight measurement from 5 randomly selected slabs each day for 10 days. You can see the 5 number of the slabs. See, you can see right here 1, 2, 3, 4, 5. You see, for 10 days. So you're asked to plot the S-batch control chart showing the daily averages with the upper control limit, lower control limit, and center line. B, to answer the question, is the concrete slab production process statistically under control? So first thing you do now is to go to Excel, start working on Excel. We need to find the mean of the sample. Okay, mean of each sample. Sample mean, let me make it here. Sample mean. So you can use the formula for average. Equal sign, type average. Okay. Average. Then for each sample, say from here to here. Oh, excuse me, I didn't get it right. Put equals average. Okay. See the first sample. 1, 2, 3, 4, 5. Then close the parenthesis. And then you can press the enter key. 5. Then let me make sure you're seeing this. Yep, you're seeing it. Enter key. All right, enter key. And then you do it for the rest of them. Copy it down to calculate the rest of them. Next is to find the range. Okay. So let's find the range. For the range, average of the range. Sorry, my mistake. Let's find the let's find the range first of all, and then you can say, well, you can find the average of the range. So the range, if you remember from your statistics class, is the largest number minus the smallest number. You can see right here, maximum data minus minimum data. Okay, and then okay, so we have the average range. Let's see right here. So, but equals max. Type in max, which is maximum. Then highlight the data here for this point. Close parenthesis, minus minimum. Highlight it again. Close parenthesis. When you press the enter key to give you the basically what this will do is it will subtract the smallest number for that row from the largest number in that row. I'll give you this, and then you can copy it down to calculate the rest of them. Okay. Then with that, you can now find the next thing, which will be the average of this range. Okay. Aruba. Okay. You have Aruba. We call it Aruba. Maybe average of this whole of this range here equals average of out right here. Have all of this and close the parenthesis. Press the enter key to give you the average. Then for this one, for the sample means, call it X bar. Okay. You get the average for that, which is this one here. That means mean of means. Okay. So you have mean of the sample means. Type again average and highlight it. Close parenthesis, press the enter key. 497.8. If you get a longer decimal place, it's like 497.7725, whatever. Make it one decimal place or two decimal places. So now, next thing we need to get is the standard deviation. Now, because we don't know the population standard deviation, we're going to be using A2, but of A2. A2. Now, how do we find A2? Remember, this is at for 10 days. For each day, there's 5 samples. Say 1, 2, 3, 4, 5. For the second day, 1, 2, 3, 4, 5. So 5 samples each. So you're gonna go to the table of values. Okay. Go to the table of values. This one here, you can see the main factor for A2. This is sample size. For 5 samples, you see that it is 0.57577. So I'm gonna write this down, 0.577. Then you go and put it right there. Okay. Now put it right there. 0.577. Okay. With this now, you can calculate our upper
Wait, can
control.
you show how you got A2 one more time, please?
Yeah, sure, of course. Remember, can you see the screen?
Yeah, I just had looked away for a second, so I
Yeah.
didn't know the formula.
So look at the actually it's not a formula, it's already calculated. It's a table. The table. So see, there's a day, each day, there are 10 days, but each day they selected samples. They weighed 5 samples. See, 1, 2, 3, 4, 5 samples for each day. For the second day, 1, 2, 3, 4, 5. So the samples is 5. So you're gonna go to the table I have the table provided for you in the PowerPoint. It's right here. Now this is sample size for under 5 for A2. So see the A2 under 5, say 0.577. That's how I got it. Yeah.
Oh, okay, so I just type 5.577. I don't.
Yeah, you get it from table. Type it in there.
All right,
Now
thank
we're ready to calculate the upper control limit, which is UCL, and lower control limit. Okay. Now this one here, the S bar is the center line already, so we have it. So we need the upper control limit and then lower control limits, and then with that we can now draw our control chart. Okay. So you can now draw it, the control chart. I'm gonna move my picture so you can see what I'm doing. I'm gonna move this. It's on this side. Okay, stay on this side. So I'm gonna put the center line. Okay, good. Now we have these numbers. This is important. Let's find our upper control limit. This is the formula right here. I'm gonna bring the formula down. Okay, so we're looking at the formula while we do it. Okay. Okay, this one. Okay. All right, I'm gonna place the formula by this end of it so you can see as we use them. Okay. Yep, I'm gonna place it down right here. Okay. Now, for the upper control limit, see the formula right here. X bar plus A2 times R bar. Remember, this is R bar, this is the X bar, this is A2. So just plug them in. Equals X bar, which is this one here, plus put parentheses, you got A2 times R bar. This times, remember, Excel is the multiplication symbol in Excel. And that gives you the upper control limit. Once you press the enter key to give it upper control limit. And the lower control limit is this one here. X bar minus. It's just the same thing. Except that in the lower control limit, you subtract. In upper control limit, you add. So you got equals X bar minus parenthesis A2 times can you hear me? Hello?
Yes, Prof.
Okay. A2 times R bar. Give me this. So I'm gonna make them to be one decimal places each. Okay, that's better. Okay. Okay. So now with this, we have all these important numbers. S bar, upper control limit, lower control limit. Plus we have the sample mean, the mean of each of the sample, the averages. We have it here. So we type in the center line here, which is the X bar, 497.8. Type it in, 497.8, because you already got it here. So you just type it in. And the lower control limit, we have it here, 484.5, 484.5. And the upper control limit, we have it at 511.1, 511.1. Okay. And then you can just copy them down. Now we're ready to draw the graph. So to draw the graph, remember you're gonna highlight from here from the same.
Can I see something real quick before you draw the graph?
Yes, ma'am. Go ahead.
For the X bar, can you put your pointer over the 497.8? I want to see the formula for it
You will not see it on this side. You're gonna see it right here on this place. Here. This
at
is
the
what.
bottom.
Yep.
Can you,
That's what we do the calculation. Average.
no, can you put your pointer on the 497.8 at the bottom?
497.8.
Yeah. I just wanted to see the
Right
formula.
here.
That's
Right
all.
here. Right here. Right. I just put it.
Yeah, click on it. Average J32 to J41.
Yeah.
Oh, okay.
The average of once I click on it, you can see the average of these numbers here.
Mm-hmm.
Mm. Right.
Thank you.
You're welcome. So now let's draw the graph. Highlight from here.
Can I see the formula for R bar?
R bar. R bar is this one here. See the average of these R's. These are the average with the R bar. Okay. Now you just highlight from here. Click on insert. This graph, choose this one here. See, to give me the graph. Now, unlike the other one we drew, this one we actually know what the data set is. I want to make it big. And what after drawing it, I'll increase it. The question was about I'm taking you back to the presentation. This question is about a construction company that use a machine to manufacture concrete slabs. So to ensure slab meets the weight specification, the quality control team collect weight measurements. So it's the weight measurement of slabs, concrete slabs. Okay, and then I think it is in pounds. Okay, so I'll call it here weight measurement. Weight measurements, weights, just weight in pounds. In pounds. Okay. So now you can see that one of them is out of control. See, you can see the okay, let me make it big. Okay. In fact, you know what? Let me copy it and paste it in Word so that we can increase the size. So you can see what I'm talking about. Okay, let's see what is paste it in Word and make it layout to be landscape. So I'm gonna paste it here. So you can see that this is the lower control limit, the green line. Upper control limit is the light blue. Then the sample mean, the weight of each slab. Since one of them goes below the lower control limit. So this process is out of control. It's not in control. So that's why I wrote here on the presentation. If you go down the presentation, you will see where I wrote the interpretation of this. Yeah, all these slides, I was explaining the steps, step by step. See, I wrote here that from the S-bar control chart, we can see that the sample mean for day 5 is clearly below the lower control limit. Therefore, the process mean is not in statistical control or is out of control. And that sample mean for day 5. And you can see that it fall and it's on the day 5. See 5 right here, day 5, that it occurred. And if you go to Excel will make it even more this thing. See, it's on the day 5. So any question about this? Any question? Well, this is what I'm gonna give you a question like this in the classwork. So this is when we're about to do the classwork, watch this video, this section of the class session of the video. Now, having shown you this, now we can look at the next type of chart. I think the next part chart we'll be looking at is the P chart. Okay. Yeah, the P chart, proportion chart. We normally use the P chart to monitor the attributes and applies to general attributes of a production process, and it applies to mainly to categorical or qualitative variables. So, which means that we can use it to analyze the proportion of the non-conforming or defective items. We call it P chart. P chart means proportion chart. That's what it means. We look at a simple application. For example, a company that make beverages like the Coca-Cola company. Every hour, in such companies, every hour there might be a random sample of about 100 bottles that can be used or that can be inspected to check for missing labels, wrong cap color, or underfilled content. So now each bottle is either acceptable or it's not acceptable, depending on the kind of problem they have. So in that case, the P charts can track the proportion of the packaging errors per sample. Now, if the chart shows an upward trend or a point outside the control limit, then that will attract the attention of the supervisors, who will then investigate the causes, which might be something like the labeler misalignment or the filler is malfunctioning. Now, for this we have maybe we can try example. But before we do that, there's some background information you need to know about constructing the P chart. Now, few things are very important though. First one is that you need a data set. Like I explained in my previous slide, it might be that some bottles are underfilled. I mean, for a beverage company, or the labeling, or maybe they did everything right, but the cover might be for a different brand. Maybe you might use a cover for Fanta Orange and put it on the Coca-Cola bottle. See, that can happen. So anyway, you need a data set. Then into get the line center line, which is the P bar, which represents the proportion of defective or non-conforming items. Then after that, you can calculate the upper control limit, and then the lower control limit, and then the proportion. Yeah. So let us apply it to this question. But before we start applying it, I want to show you some of the computational formulas. For the P-bar, use this. Total number of defectives divided by total number of total number sampled. Now, for the upper control limit, you use P bar plus 3 times square root of P hat times Q hat over N. For P hat, use for Q hat, use 1 minus P hat. Then N bar is what I call it hat, not is a bar, not hat. P bar and the Q bar, and then N bar is average of the sample sizes. And the lower control limit is P bar minus 3 times square root of P bar times Q bar over N. Then the proportion itself is the number of defective divided by sample size. So let's try an example. It said here that power cell technologies. Make sure you're seeing this. Yep, okay, good. Power cell technologies is a top-tier US manufacturer of advanced car batteries. To ensure the product reliability, the company conducts daily quality inspections by randomly selecting 250 batteries from the production line. Each inspected batch is checked for defects, and the number of defective units is recorded. The quality control team has gathered the following data over a 15-day period. So I'm going to show you data, what they gathered over a 15-day period. Let me show you on the Excel. See, so yeah, over a 15-day period. So they're checking in batches of 250 sample size. They check each day, they check a sample size of 250. It doesn't have to be 250 all the time. Sometimes it might be 250, next day it might be 300, next day it might be 280. So it doesn't have to be equal sample size all the time. Anyway, I think you get the point. So now this data I show you, and it says here, what is it? Where is it? Using the data provided, construct a P chart to analyze this proportion of defective car batteries produced by power cell technologies. Then B, based on the P chart, determine whether the process is in statistical control or not. Justify your answer by referencing whether any points fall outside a control limit. So the first thing to do when you have this kind of thing is to look at the data set. I just showed you how it will look like. It's right here. Okay. Next is to find the total here. So total will be for this one, okay. These are the defective items here. Total will be equal sum. Okay, double click and then highlight all of it. Okay, close it and then press the enter key. Give 180. And for this one, total is just copy it because it's the same row. See? Excel will copy the formula here and get the total for the sample sizes. Okay. Now with this, we can now find our P bar. P bar, which will be according to the what I have on the presentation formulas I gave you. P bar is the total number of defectives divided by the total number sampled. Okay. So you have total number of defectives, which is this divided by total number sampled. This one here. Then press enter key. Give me 0.048. Then Q bar is 1 minus P bar. It gave me 0.952. The N bar, if you look at the formula for N bar, I always recommend always play the formula by your side while you're doing this. N bar is the average of the sample sizes. Average of the sample sizes. So I'm gonna put it in this way for you. Let me see if Excel can give us allow us to use formula here. Okay, I'm gonna use it here. Bring it down here. Make it a little bit big. Oops. Okay, let's see. So what I'm trying to get is the N bar. Okay. So where are we here? Okay, here N bar maybe okay. What is it? Right here. N bar. I'm gonna type small N bar.
Do we have to write this too?
No, I'm just putting the formula for you.
Oh, okay.
And you don't have to write anything. But the one you solve, I'll put it in the classwork section after the class. So
How'd you get that in bar?
huh?
How'd you get the in bar just now?
Oh, you mean how I got it from Excel? I don't understand.
Yes, from the building formula.
Oh, yeah, from the formula here, just here. Insert, right? Okay, if I just click inside it here, this is where I got equation. Now, see this A? Can you see this A? With
Yes.
to here, that's where I get it from. Click on this and then choose from here. Then type
Oh.
type N bar equal. Let me make it a little bit bigger so that you can see it properly. Okay. Equals what is it? Stay here. Equation equals you're gonna use total number sampled, number sampled, okay, divided by the number of days. After this, I'm gonna delete it so that we have enough room for this. So now that's the end right here. Total number sampled equal is this is the total number, this is the sample size. So total number of sample is this one here, divided by number of days. Number of days is 15 days because they are doing it each day. They sample 250 of them and then find the defective item in those 250. So it's 15 days. So I'm gonna type 15. Okay. That'll give me 250 for n bar. Now we are now ready to calculate this. So I'm gonna do so we can see this room. Calculate the this part of the formula. I'm gonna show you what it is. See this part. Usually, sometimes Excel, if you don't put it the right way, you might not follow the. Sometimes if you don't put it the right way, you might not follow the order of operation. So that's why you get to get this part first. Once you get it, you subtract it to get the lower control limit. Then add it to get the upper control limit. So let's go back there. So you have this to get this part. See 3 times the square root of. Okay, let me show you again. That part is 3 times the square root of p bar times q bar over n bar. So I'll show you how you can put it in Excel. Equals 3 times. Okay.
Is this gonna be recorded and posted?
Well, you mean the video?
Yes.
It's been recorded, yes. 3 times. Okay.
This is a classwork, right?
No, it's not the classwork. I'm just teaching you how to do it. Then I'll give you the classwork that you can do. This one is me doing it, not you doing it. Okay. So we got 3 times p bar time. Oh, sorry, my mistake. 3 times the square root, which is SQRT. Excuse me. P bar times Q bar divided by the n bar, which is this one here. Close parenthesis. Okay. Then press the enter key. It gave you that. Usually make it 3 decimal places. Good enough. Okay. So now with this, we can now get the upper control limit and lower control limit. We have here upper control limit to be according to the let me move and show you in Excel. If you have a question, ask me. I don't answer question in the chat room. Okay. Upper control limit is p bar plus 3 times square root of p bar times q bar by n. And lower control limit is the same thing, except that you have a minus sign on this side. So that in this case, the upper control limit, upper control limit equals p bar plus, okay, we already got this part. It's 3 times this. We have it, so all we just need to do is to put the minus sign. We got it here already as this 0.041. So click on it. I'll give you the upper control limit. And then lower control limit equals, again, p bar minus this one here, 0.007. Now, with this, next thing we need to get the sample proportion, this one here, sample proportion, which is simply means the number of defectives divided by sample size. That means equals this one here divided by this one here. When you press the enter key, it will give you the sample proportion. And then you can, copy it down. It will do the same thing for all of them. Now you're ready to draw the control chart. So I'm going to move this here so you can have enough room. You're ready to draw the P chart. We get the center line bar from that. This is a P bar as 0.048. 0.048. Type this one in because you already calculated it here. So just type it in here. Lower control limit, okay, is 0.007. You got 0.007. 0.007. Okay. Then upper control limit is 0.089. 0.089. Then you can just highlight and copy them down. Okay. For all of them. With this, you are ready to draw the graph. To draw it, you just highlight everything. Click on Insert. The chart, choose this one here. Okay. This is because we know the data set. The data comes from this company question. Okay. No, it's from this one. Sorry, my mistake. Yep. The Power Cell Technologies, top tier US manufacturing and manufacturer of advanced car batteries. So to ensure the reliability, the company conducts daily quality inspection by randomly selecting 250 batteries from the line. Each is inspected for batch. Each inspected batch is checked for defects. And then, so we know the Power Cell Technologies, I'll call it control charts. Let me call it this way. Oh, excuse me, my mistake. I went to something else. I'll call it the P chart. P chart. P chart for Power Cell Technologies data. Or I can just call it P chart. P charts. Let's call it number of defectives. Number of defectives. Now you can see that this one is under control. See the line. Sample, see blue line. This is the center line. This is the upper control limit. This is lower control. So it's unlike the other one with drill. This one doesn't go below the lower control limit, and it didn't go above the upper control limit. So this process is under control. So that you can write the graph. Okay. Let's see. Interpretation of this. Okay. The P chart. The P chart shows that this manufacturing process is under control. Okay? It's under control. Unlike this one that we did before, when we draw the S bar chart. I see that this one went below the lower control. Yes, one of the days there's a one that the weight was below the lower control limit. This process is not under control. But this last one we use P chart. P chart shows that it's in control. Okay. So
Can I see? Sorry.
Go ahead. Go ahead.
Can I please see the bottom of this?
This one here.
Yeah, scroll down, please. Where you got the UCL, I was just wondering how we're supposed to input that formula. If you click on 0.089, I just want to see that formula, how you enter
Yeah.
it. Yeah. Oh, C21 plus C24.
Yeah, because we already calculated the this part. Let me show you. This part of the formula, this part that's at
Mm-hmm.
3 times square root of
Mm-hmm. How do you enter that whole thing?
yeah, we calculated it right here on the right here. So what you have to do now is to subtract it to get the lower control limit, then add it to get the upper control limit.
Okay.
All right.
Thank you.
For sure, you're welcome. So I'm gonna put the one that we'll be doing. I'm gonna be putting it here, and right, I'm gonna be putting it on the classwork in a few, as soon as I because I want to upload this video before I can put it so that you can watch the video. So you can watch the video before you start working on it, or as you work on it, so that if you get confused, you can just look at the video. Alternatively, because the one I'm going to give you is not the picture, I'm going to give you the X bar chart. In the X bar chart part, this one, you can either watch the video or you can follow the example in question 2. I show the step one by one. Okay. So any question before we leave?
Prof, sorry.
Go
It's
ahead.
okay. I just want, so just to be clear, for this classwork, are we uploading what we just did?
The classwork, I'm going to give you a question for it.
Oh, okay. All right.
Any other question?
Prof, you said this week, like assignments that we didn't do well in, we can redo them.
No, I
But
didn't
for
say
me,
that. No, I didn't say that.
oh,
What I say that if your attendance is 70% or more, then you can request to make up 4 assignments. So how do you do that? You send me an email and list the names of the assignments that you want to make up. Then I'm gonna give you something that you do to make it up. You cannot redo assignment that is already graded, okay, and you want to do the same question. You can that one. I'm gonna give you something to do, something else to do. Then, depending on your grade on that work packet that I will give you, then I'll use it to upgrade the grade in those assignments.
Excuse me, I have a question about that. Would that be for the whole group or is this
No, this is
individually?
individually.
Okay.
Any other
I
question?
did email you. I emailed you because from the beginning of the class, I missed the first 2 classes. So I didn't get to do those classwork. So I wanted to redo 1A. I think it's 1A, 1B or something. I emailed you. So you can please send me the questions for those two.
When did you send the email? The
Uh,
number is from this week.
yeah, I sent it this week.
Okay, now I will start looking at them this weekend. If you send it this week, you just have to be patient. I will go through
Yes, I
them.
sent it yesterday.
Oh, okay, so probably by Saturday, I'll be giving those questions out to those who qualify. Any other question?
Okay.
Yes,
If you
sir,
don't,
Professor.
if you don't have any other question,
Professor,
you are free to leave.
yeah, Professor. I sent you an email about attendance. I was here for a couple classes, and I got marked as not being here.
If you're not here, you can't be marked present. So,
No, I was here, but
what's your
somehow
name?
Eric Washington.
Huh?
Washington, Eric Washington. It's a couple weeks ago. I was here during Zoom. It was like 2. I got marked absent for it, and I was here.
Last week we didn't have a class last week.
No, not last week. I sent you an email when y'all didn't mark me present.
So, do you have the exact date?
Yeah, do you want me to send you an email?
No. I have my attendance paper here with me. Let me see if it's an error.
Let me try to find. Let's see.
Washington, right?
Yes, sir.
Professor, I have the same issue. I think you're missing one of the classes I was in.
There was a day that
There's at least like 2 classes I missed. I mean, I got marked as missed, although I was there during the Zoom.
you came late on that day?
Say it again.
Did you come late on that day?
Not likely.
Send me the email about this. Let me look at the
Okay. All right, thank you.
Everything.
All right.
Professor, I just wanted to clarify that classwork 8 is due with our group. I think I overheard you saying that one of the assignments were going to be turned in individually, and I just wanted to make sure which.
No, what I say that the makeup. If you fail an assignment that you want to make up, and if you qualify, you send me email with the name. If your attendance is 70% or more, that is the one that you're doing individually, not like say you failed you didn't do well in, let's say, classwork 2. Then and the attendance score is 70% or more. You can send me an email that you want to redo. You can just look at the assignment up to 4 of them that you want to redo, Send me an email, put their names. Then I'll send you something to do. So then in that case, it is not group, it's you that I'm sending it to.
Okay. And classwork 8, is there any way that we can turn it in tomorrow, or that has to be due tonight?
Don't say we, it's you.
For classwork 8?
Oh, sorry, my mistake. Classwork 8 is this week, right?
Yeah, I was wondering if there's a way we can turn it in tomorrow, or...
You can turn it in tomorrow, of course.
Okay.
It's due today, but I can accept it tomorrow.
Okay.
I have not even put it in yet because I want to record this video so that you can be watching it as you do it,
Okay. Thank you.
Welcome. All right, guys. I guess I have to leave you now, eh?
Okay. Wait. I have one. Do you want me to just email you because you're missing one of my attendance?
Do the same thing
as well.
Do the same thing.
So okay.
Don't forget to put the date so I can.
Okay, so that's the thing. Like, it doesn't. I don't think it shows me the dates which ones you marked me and didn't mark me. It just shows me
but you know the date that you say I don't. We have this class every Wednesdays.
Yeah. Okay. I can tell you which day I missed. All the other dates I didn't miss because there's only one class that I missed.
How many classes do you mark absent?
You mark me absent for 2. Like, me and my group.
That's the one I want. Those 2 days, so I can look at my attendance.
Okay, and that's the thing. It doesn't tell me which date that you marked me absent for. It just has a overall attendance grade.
Okay, so send me the email. I will look into it.
Okay, I'll send you the screenshot so I can show you that it doesn't show us the date.
Yeah, if you have no, what I'm saying that just send me. I will look at my attendance because I read them. I marked them on my paper too. I'll look at them.
Okay.
All right, guys. Have a nice evening.
Professor.
Thank you, Professor. Have a nice night.
Thank you, Professor. Good night.
Yes,
Professor, I got one question.
Okay.
All right.
Okay.
I had a question. When is those makeup work due?
What do you mean?
When is the makeup work that we have to do? When like the second week of April makeup work?
No.
For assignments?
But when it comes to makeup, don't say we because makeup you are on your own.
Yeah. I'm saying I said week.
If your attendance is good, right?
No, I said 2 week. The second week of April. That's what I said.
Well, I'm taking it now. The email.
Even though it's the third week.
If the attendance is good, you can send me the email and list the names of the homework or classwork that you want to make up.
Okay.
So you send it. Don't forget because every assignment in this class have a name. Like you have classwork 1, test. So send me then I will now look into that. But remember, this is a one-time thing. So
got you.
I will. If you ask me, I will say send this next week. But if you send it this week, I will give it what to do. Okay.
All right.
You know why I say because I have not graded the test 1.
Yeah.
So but if you want, you can send it this week today, and I'll give you by weekend. I'll assign it to you. Name if your attendance is above 70% only.
All right, bet. Got you.
All All
And
right.
Professor, it's the last one. It's the last one, Professor. I know you have a family and stuff. I know you got your free time, but I need some help, my man.
Yeah, go ahead. What do you need?
So for my assignments, I know I'm doing them correctly, but I'm receiving a lot of zeros on my grade book. I don't check my grades too often because I'm submitting them, assuming that I'm doing good on them. But the notes that I see that you put are my work.
This is the one, right?
Yeah, that's correct. So how am I supposed to show my work in the Excel? Because I'm confused. Because I know I'm doing it right. I'm inputting all the right stuff. I'm watching
Okay.
all the videos. But
You use the same formula, the same way I'm doing it in class. Like this one we just did, right?
yes, sir. Of
Look at
course.
it. Like if I'm grading it now,
Mhm.
first thing I'm gonna do is look at this calculation. See, if I click on it, can you see the screen here?
Yes, sir.
It shows me what you did. If I click on it, now if you submit, because if you look at my instruction for each classwork, I said this must be done in Excel.
Of course, yeah.
So,
All my
so,
work.
so I can verify it. But if you submit a PDF file, if I click on it, it won't tell me anything. It will just look like answer that I typed in.
Okay, gotcha. Because I know, because I like I said, I'm Excel certified twice. So it's like I know I'm putting the correct formulas in, but every single class was different.
There's the one I graded today. You submitted a
Yeah,
PDF.
yeah, I know that
I
one
can't
I know.
verify it. I cannot
Yeah,
verify the answers. But if you have submitted a Excel, all I gotta do is to click on your answer. It will tell me, show me your work. It will show the work on the top here. Can you see the top here?
I think your screen is. I think your screen is frozen.
Hold on. Let me see. Yeah, okay, I'm here now, right? Watch me.
I see you in Canvas.
You
Yeah.
You can see it now,
Yep.
right?
Yes, sir.
So when I click on this, right?
Yep.
You look at the top, you see the answers. The work.
Yeah, exactly. That's what
Uh-huh.
I'm doing. So for my previous classworks, I submitted Excel, but you said the same things. But I know I'm not just inputting information. I'm using the formulas like you taught us.
Well, but if you are doing it, if I click on your answer, it will show me the work. Like now, let me show you. I forgot the one I graded today.
But I know the one today was a PDF. I'm aware of that. I know. I seen that I submitted that PDF, so it looks like there's no work. You can't check it. I understand.
Yeah.
It's just the ones in the past I submitted them Excel, but you said the same thing.
Yeah, if I click on the answer you put in there, if it doesn't show me the evidence, that means it's typed. Because if you type it in, like now, if you see this one that I typed in, look at this one I typed in here. See, look.
Yeah.
Here, see, I typed this one in. So if I click on it, it will just show me the number.
Yeah, no, which I'm aware. You know what I mean? I'm aware of that, but it's just I'm like I said, I'm doing everything step by step. You know, I'm watching the videos, and I'm not just typing in numbers because I'm sure I know the difference between typing in the number versus using a formula. It's pretty straightforward. It's not hard. You know what I mean? It's just that I'm surprised that.
But when I click on your answers, it doesn't show me the work. That's what I'm saying. If you do the calculation, if I click on it, except just anything you do, it will click on your answer, it will show everything you did. Yeah.
That's weird. Okay. I mean,
so remember you still have your attendance. I know you already, so I know that attendance is good. So because if I don't want to put it on the screen, your attendance is up to 70% or even more than that, right? Am I right or wrong?
Yeah, you're right. It's like 78 or something
So
like that.
you have 4. You can make up 4 of them, and from now on, don't submit PDF because all my listening is if I attend that, so send me the email to the names of the classwork that you want to make up. So this time around, be careful this time around so that any work you do, make sure that when you click on the cell, even before you submit it, you can check it yourself. Make sure that it's showing the work.
That's fair, but let me ask you this: if there's a way I can prove that I use the formulas, I know I use the formulas. There's no way I don't because it doesn't make sense to be in this class.
That's the only way you can prove it is to do like the way I did it here. Once you do the calculation,
it should pop up at the top.
Yeah. So just do the calculation there. It will pop up by itself. So when I grading it, I'll click on your answer. It will show me exactly what you did.
Okay. That's fair. Yeah. I got you. So I'll send you an email the ones I want to resubmit.
Yeah, sure.
Not resubmit, but
no, don't resubmit. You send the email. I know. You send the email. I'm gonna give you a work packet that you will do, and then do that. Their score on that will take care of those ones that you want to make up.
Okay.
Mm,
Gotcha.
yeah.
All righty. I
All right.
appreciate that.
Oh, sure. You're welcome.
All right.
All right, guys.
Hey,
Huh?
I've been having a similar problem to where I haven't been getting credit for my assignments,
This
and
is it Tolliver?
this is me, Evan Taylor.
Yes, Taylor, Mr. Taylor. Like the one I graded today, you didn't submit. You submit the wrong assignment there. You didn't submit what I asked you to submit. Like I'm gonna show you. Hold on.
Like, I want to make sure I have the right documents.
See, look. Let me check the one I graded today. What is it? What is it? What is it? Yeah, like this one now. This classwork 7, right?
Yes, that's
I gave
right
you
there.
instruction. Can you see the screen?
Yes.
I gave you very specific instruction. Um,
Yeah, the handwritten
draw
essay.
this. Can you see the screen here? I
Yeah.
said draw the full chart by hand on paper. Do not type or print. Now, let me show you what you did. What's the name again?
Evan.
Hmm?
Evan.
Well, I want to pull your work, so that's why I'm asking. What's your first name?
His name Ronald.
Ronald. Okay, Ronald. Yep. Mr. Ronald, right? Is that you?
Yeah.
No, since you go exactly do what you did exactly what I said don't do. You are typing them. Everything, see, everything you did submitted here was typed. See? I said hand. Okay, that's number one. Next one is I think it was the one I graded today. Let me see, got the models. Hmm. Hand drawn. I think not this one. There's one I graded today. Uh, what is it? What is it? What is it? Oh, I think I'm gonna find it. I have the listing here with me. It was
Yeah, there was a
it
few
was
of
a
them. There was
classwork
the hand-drawn
classwork
assignment.
it was classwork
And
5. Classwork
yes,
5.
that one.
Classwork 5. Mr. Are you with me here? Classwork 5.
Yes.
Exponential smoothing. I'm gonna open it now. And I say it here. Watch the video and then answer this question. Now let me show you what you did.
I watched the video.
Yeah, but then you didn't answer the question. You submitted something else. Let me show you. So each time I grade something, please go and read my feedback there because it will tell you what you did so that you will not get confused on why you fail it. Each of them I write a feedback. That's you right here. This is not what I asked you to do. You submitted what you did in the class. That was see? Can you see what you submitted?
So which one was the right document? If this isn't the right document.
This is the right question here. The question is right here. This is it says here questions. And I said watch the video, then answer these questions.
Okay.
Then follow the step from the video to answer it. But what you did was something else. Okay. Now, your attendance, your attendance is it 70% or more?
It's 100.
Huh?
It's at 100 right now.
It's 100?
Yeah.
Okay. That is a good thing. But before I say something, let me show you something here. Yeah, that's you. So you did some. I think basically what you did here, the thing we did in the class, you just uploaded it here, which is not here, and I wrote it here. You can see my feedback. You submitted the wrong assignment here. So always read my feedback so that you know what you are doing wrong or right. Don't just look at the grade book and say you didn't get credit. Go to the assignment, click on it so that I can see my feedback. What I say, what happened, why you have that grade. Okay. So you know what you're gonna do now, eh? Since your
Yes.
attendance is more than 70%, what you're gonna do, write the name of those assignments that you failed. Now, no, I always I say four for everybody, but for you, I'm gonna say five of them. Write the name send me an email, write the name of the five assignments that you failed, and then I'm gonna reply maybe by Sunday and give you a work packet that you will complete. And then email back to me. Please make sure you follow the direction exactly. Don't do something else. Because if you do something else and submit, it's not gonna push up your grade. If you want more time, I can give you more time. Follow the instruction for each question exactly. Okay? So I'm expecting your email tomorrow. List
Yes.
of the names of five, for example, each assignment in this class have a name, like classwork 1, classwork 2. So list 5 of them that you failed. I'm giving the class 4. Those that have it, but for you, I'm gonna give 5 that you failed that you want to make up. Then in my reply, I will give you the work to do to make them up. And in that work, make sure you follow the directions exactly. Don't go and do something else and submit and email it to me. Okay? All right. I see you next week.
Yeah.
All right, guys. You guys have a nice evening.
I just have a question.
Yes.
So just like you said, we just email you the 4 assignments that we failed.
Only if
And
your attendance is 70% or more.
okay, well mine is. And did you mark me today? Sorry, my computer had died mid-lesson, so I had to rejoin on my phone.
What's the name?
Thompson, Aloria.
Yes, I marked you.
Okay, I just wanted to make sure because, like I said, my computer had died, so I had to join back on my phone.
All right, then. See you next week then.
See you next week. Thank you.
You're welcome.
Is next week going to be online as well?
I don't know yet. Well, if it's going to be, I will let you I'll put an announcement.
Okay, could you possibly let us know like Sunday by chance? Because I kind of have like a conference to go to. I would still be able to join class, but if you hold class in person, I won't be able to go. I'll still be able to be attentive while I'm at the while I'm at the conference. I'll just step away.
No, what you're gonna do is if you are I wouldn't know by Sunday. I'm a very busy person, so it depends on
Yeah.
what happens. But what you're gonna do is if you feel that if it's going to be a campus class, if you are missing, just send me email before the class that you're in conference, you couldn't make it. Then even if I mark you absent, when you come back, just let me know. I will update it
Okay.
because you already sent me the email before that.
Okay. Thank you so much.
You're welcome.
Bye bye.
Goodbye.